Hello everyone, I'm Professor Diwa and welcome to another math video. In this video, I'll be going over rational equations and problem solving. Our objectives are to solve an equation containing rational expressions for a specified variable, solve number problems by writing equations containing rational expressions, solve problems modeled by proportions, solve problems about work, solve problems about distance, rate, and time. Alright, so let's get started. For example number 1, solve for the given variable. For part A, we have 1 over A plus 1 over B equals 1 over C. We need to solve this equation for the variable C. First, we need to get rid of the fractions by multiplying by the LCD, which is ABC. We get ABC times 1 over A plus ABC times 1 over B equals ABC times 1 over C. Next, we simplify the equation, starting with the first term. We could cancel out the a's. We get BC times 1 is BC. For the second term, we could cancel out the b's. We get AC times 1, which is AC. And for the third term, the c's will cancel out, and we have AB times 1, which is AB. The result is BC plus AC equals AB. Next, we could factor out a common factor of C from the BC plus AC. The result is C times the parentheses B plus A equals AB. Next, we want to divide out the B plus A on both sides of the equation. We get C times B plus A divided by B plus A equals AB divided by B plus A. Simplifying the left-hand side, the B plus A's will cancel out, and we just have C. And on the right-hand side, everything stays the same. So our final result is C equals AB divided by B plus A. Moving on to part B, we have x over 1 plus y equals z. We need to solve this equation for y. First, we get rid of the fraction by multiplying both sides by the LCD 1 plus y. We get parentheses 1 plus y times x over 1 plus y equals z times the parentheses 1 plus y. Simplifying the left-hand side, the 1 plus y's will cancel out, and we're left with an x. Next, we bring down everything on the right-hand side. We get x equals z times the parentheses 1 plus y. Next, we divide both sides by z. We get x divided by z equals z times the parentheses 1 plus y divided by z. Simplifying the right-hand side, the z's will cancel out, and we're left with 1 plus y. On the left-hand side, we just bring down the x over z. The result is x over z equals 1 plus y. Next, we solve for y by subtracting 1 from both sides of the equation. We get our final answer, y equals x over z minus 1. For example number 2, if a certain number is subtracted from the numerator and added to the denominator of 9 over 19, the new fraction is equivalent to 1 over 3. Find the number. To find the number, we're first going to start off with 9 over 19. We're going to subtract an unknown number from 9 and add that same number to 19. Because we don't know what that number is, we could represent it with the variable x. We also know that this new fraction is equivalent to 1/3, so we could set this equal to 1/3. So we have 9 minus x over 19 plus x equals 1 over 3. Next, we get rid of the fractions by multiplying by the LCD, which is 3 times the parentheses 19 plus x. So we have 3 times the parentheses 19 plus x times 9 minus x over 19 plus x equals 1 over 3 times 3 times the parentheses 19 plus x. Next, we simplify. On the left-hand side, we could cancel out the 19 plus x's, and on the right-hand side, we could cancel out the 3's. The result is 3 times the parentheses 9 minus x equals 19 plus x. From here, we could distribute the 3 inside the parentheses to the 9 minus x, and then bring down everything on the right-hand side. The result is 27 minus 3x equals 19 plus x. Next, I subtracted 19 from both sides, and I added 3x to both sides. The result is 8 equals 4x. Next, we get rid of the 4 in front of the x. We just divide both sides by 4. We get 8 over 4 equals 4x over 4. After simplifying, the result is x equals 2. For the final answer, we just write that the number is 2. For example number 3, in the United States, 8 out of every 25 homes are heated by electricity. At this rate, how many homes in a community of 36,000 homes would you predict are heated by electricity? First, we start off with the rate, which is 8 over 25. This means that 8 homes are heated by electricity out of a total 25 homes. Next, we set up a blank proportion, so I have 2 fraction bars equaling each other. I know that the numerators of the fractions represent the number of homes heated by electricity, and I know that the denominators represent the total number of homes. So on the left-hand side, I put 8 over 25, and on the right-hand side, I have x over 36,000. So I have 8 over 25 equals x over 36,000. From here, we need to solve for x by cross-multiplying. We get 8 times 36,000 equals 25x. Simplifying the equation, we get 288,000 equals 25x. Next, we divide both sides by 25. We get 288,000 divided by 25 equals 25x divided by 25. After simplifying, we get x equals 11,520. Our final answer is that there are 11,520 homes heated by electricity in a community of 36,000 homes. In example number 4, it states, the roof of Corey's house needs to be reshingled. Corey can finish the job alone in 8 hours, and his friend Hunter can do the same job in 10 hours. How long will it take the two of them working together to reshingle the roof? This type of problem is what we call a work problem, which uses the equation rate times time equals work. To help us set up our equation, I'm going to use a chart. So I have 3 rows and 3 columns. For the first row, this represents Corey, the second row represents Hunter, and the last row represents them working together. For the first column, this represents time, the second column represents rate, and the third column represents the work. Next, let's fill in our chart. So we know that Corey takes 8 hours to complete the job by himself. We also know that Hunter takes 10 hours to complete the job by himself. The time it takes for them working together is what we're trying to find. So we're going to use T to represent the time it takes for them working together to reshingle the roof. Now the rate is how much of the roof they could complete in 1 hour. Since it takes Corey 8 hours to complete the roof by himself, his rate would be 1 over 8, which means he could complete 1/8 of the roof in 1 hour. Since Hunter takes 10 hours to complete the job by himself, his rate would be 1 over 10, which means he could complete 1/10 of the roof in 1 hour. The rate for them working together would just be 1 over t, meaning they could complete 1 over t of the roof in 1 hour. Next, we have the work column. Every entry here should just be 1, meaning that the work to be done is to complete 1 job or 1 roof. If we multiply Corey's time by his rate, so 8 times 1 over 8, this is equal to 1, meaning that he could complete 1 roof. Same thing for Hunter. His time is 10, multiplied by his rate 1 over 10, we get 1. We also have the same result for them working together. We have t times 1 over t is equal to 1. Next, the equation we need comes from the column for the rate. We add Corey and Hunter's rate together and set it equal to their rate working together. We get 1 over 8 plus 1 over 10 is equal to 1 over t. In order to solve for t, we need to get rid of all the fractions by multiplying by the LCD. The LCD for this equation is 40t. We get 40t times 1 over 8 plus 40t times 1 over 10 equals 40t times 1 over t. Next, we simplify. For the first term, 8 divides into 40 5 times. We get 5 times t times 1 is 5t. For the second term, 40 divided by 10 is 4. We have 4 times t times 1 is 4t. For the third term, we could cancel out the t's. We have 40 times 1 is just 40. So the result is 5t plus 4t equals 40. Next, we simplify the left-hand side by combining like terms. We have 5t plus 4t is 9t, which is equal to 40. Next, we get rid of the 9 by dividing both sides by 9. We have 9t divided by 9 equals 40 divided by 9. After simplifying, we get t is equal to 40 over 9. Plugging this into the calculator, this fraction is approximately equal to 4.4, so I rounded to 1 decimal place. Our final answer is that working together, it takes them 4.4 hours to reshingle the roof. In example number 5, it states, Steve takes 1.5 times as long to go 72 miles upstream in his boat as he does to return downstream. If the boat cruises at 30 miles per hour in still water, what is the speed of the current? This is a uniform motion problem which uses the distance equation, which is rate times time equals distance. To help us set up our equations, we're going to use a table or this chart where we have 2 rows and 3 columns. The first row represents going upstream, the second row represents going downstream. The first column represents time, the second column represents rate, and the third column represents distance. Next, let's go ahead and fill in the chart. We know that it takes 1.5 times as long to go upstream than it does for Steve to go downstream. Because the problem didn't state how long it takes for Steve to go downstream, we're going to represent this time using the variable t. This means that the time going upstream will be 1.5t. Next, we need to fill in the rate. The problem stated that the boat cruises at 30 miles per hour in still water. Now, when the boat is going upstream, it's fighting against the current of the water. So we need to subtract the speed of the current from the speed of the boat when it's going upstream. Because they didn't tell us the speed of the current, we're going to represent this with the variable c. So going upstream, the rate is going to be 30 minus c. Now going downstream, the boat is going with the current, meaning that the current is actually pushing the boat, making it go faster. So going downstream, the rate is going to be 30 plus c. Next, we need to fill in the distance column. We know that the distance going upstream and downstream is the same, so we just write 72 for both entries. Next, we get the equation for each row by multiplying the rate and time and setting it equal to the distance. So going upstream, we have the equation 1.5t times the parentheses 30 minus c equals 72. The equation for going downstream is t times parentheses 30 plus c equals 72. Now we have 2 equations with 2 variables. We could solve this using the method of substitution or elimination. For this problem, I'm going to use substitution. So I'm going to solve both equations for t and then set them equal to each other. Solving the first equation for t, I'm going to divide both sides by 1.5 times the parentheses 30 minus c. So I have 1.5t times parentheses 30 minus c over 1.5 times parentheses 30 minus c equals 72 over 1.5 times the parentheses 30 minus c. After simplifying, the result is t equals 48 over 30 minus c. Next, we solve the second equation for t. We just divide both sides by 30 plus c. We have t times the parentheses 30 plus c divided by 30 plus c equals 72 over 30 plus c. After simplifying, the result is t equals 72 over 30 plus c. Next, we set both equations equal to each other. We get 48 divided by 30 minus c equals 72 divided by 30 plus c. To solve this equation, we start off by multiplying both sides of the equation by the LCD, which is 30 minus c times 30 plus c. We get parentheses 30 minus c times 30 plus c times 48 over 30 minus c equals 72 over 30 plus c times parentheses 30 minus c times parentheses 30 plus c. Next, we simplify. On the left-hand side, we could cancel out the 30 minus c's. We get parentheses 30 plus c times 48, which is just 48 times parentheses 30 plus c. On the right-hand side, we could cancel out the 30 plus c's. We get 72 times parentheses 30 minus c, which is just 72 times 30 minus c. The result is 48 times parentheses 30 plus c equals 72 times parentheses 30 minus c. Next, we distribute the 48 inside the parentheses to the 30 plus c, and we distribute the 72 inside the parentheses to the 30 minus c. The result is 1,440 plus 48c equals 2,160 minus 72c. Next, we could do two steps at once. I subtracted 1,440 from both sides, and I added 72c to both sides. The result is 120c equals 720. Next, we get rid of the 120 by dividing both sides by 120. We get 120c divided by 120 equals 720 divided by 120. After simplifying, the result is c equals 6. Our final answer is that the speed of the current is 6 miles per hour. Alright, so this is the end of our video. Thank you very much for watching. I'm Professor Diwa, and I'll see you in the next one.